Welcome back to another video on double A learning. Today we're going to be sticking with a math topic, and it's going to be algebra again, and it's going to be systems of equations. So before we get into systems of equations, you guys should definitely watch my slope-intercept form video that I uploaded, because that's going to be kind of helpful for this topic. But basically, what systems of equations is, it uses systems of equations uses the knowledge of linear equations. So it basically uses the topics that we learned in last video to add on, basically. So I'm just gonna go over like a quick refresher. But if you guys get confused over like how to find the slope or something, make sure you guys actually refer back to that video. So yeah, we need to realize that m in slope-intercept form, which is y is equal to mx plus b, and you realize m is the slope. That's going to stay true here. And then we need to realize that b is equal to the y-intercept. And that in order to, some ways you can find m or the slope are through the equations of rise divided by run, or the other equation y2 minus y1 divided by x2 minus x1. Okay, yeah, those are like the key concepts you guys should know like before going into like the system of equations, but just as a quick refresher, just remember these rules. Okay, let's get into what systems of equations are. Alright, so our question is, what are systems of equations? Okay, so basically, systems of equations, they usually have 2 plus equations that are solved together. They also must share the same variables. So this could be like x comma y, or like a, b, or something like that. I'm just going to leave x, y here as an example. And then third, they can be determined through they can be determined through graphs or algebra. So either way, you guys can solve these systems equations, and I'll show you guys an example of that. Okay, so our first example, I'm just gonna label 1. So we're gonna have, in system equations, we'll be given one equation. For in this case, it would be y is equal to x plus 2. And I would be given another equation, and it usually be written like right under it. Y is equal to negative 2x plus 5. And this one we're gonna solve graphically. Okay, so let's just draw our graph right here. Again, this is gonna be a sketch, so it's gonna be like really rough. And draw our coordinates: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. In like a test or exam, I suggest you guys label like how much increments you guys are increasing each of the x and y axis, just so it's clear to like your teacher or professor. Okay, so let's graph first just this graph right here. Y is equal to x plus 2. So again, let's find the slope. So we know the slope is 1 because there's an imaginary 1 here, and we know the y-intercept is 0 comma positive 2, because if we plug in 0 for x, we get positive 2. So let's graph that. So that would be right here. 0 is x and 2 is the y. So now let's graph x. Let's put in 1 for x. So you put in 1 for x, that becomes 1, comma, the x's value is 1, the y value is 3. So go up. And that makes sense because our slope is rising up 1, running 1. So if we just follow that pattern, we'd have some graph that looks something like this. And we can draw the other side like that too. Okay, that was our first graph. Now let's graph our second equation. Y is equal to negative 2x plus 5. So if we plug in 0, we know that the y-intercept would be at positive 5. So x is equal to 0. And then 1, 2, 3, 4, 5 right here. And then the slope is negative 2. So let's just plug in 1 here. So if we plug in 1, then it'd be negative 2 plus 5, which is 3. So 1, comma 3. And that's that point right there. And let's just draw the graph. So it will look something like this. Okay. Just based on these graphs, we can tell that they intersect at the point 1, comma 3. So what this intersection point tells us is that that's where the two equations are equal to one another. And that's what systems of equations are. We're basically trying to find out where these two equations satisfy each other. So in this case, we find that this graph only has one solution. Some cases, graphs can have no solution or infinitely many solutions. And I'll get into some examples of how those look. But for this case, you guys need to know that these two graphs have one solution because their slopes are different from each other and their y-intercepts are different from each other. So they're bound to touch at one point. Okay. Yeah, let's go into the next graph. Okay, so our next graph is gonna be, we're gonna use a different equation. It's going to be y is equal to 2x plus 4. And then the other equation, y is equal to 2x minus 1. Before we get into this, I just want you guys to make a prediction. So last time we had one solution. What do you guys think this one's going to be? Okay, so let's just graph this. Let's just draw a graph here. Again, this is a sketch, so take it with a grain of salt. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So let's first graph the first equation, 2x plus 4. Let's use our same graphing techniques. We know the y-intercept is 0, comma 4, so 1, 2, 3, 4. And then draw that point right there. And then x, let's plug in 1, so 2 plus 4, that's 6. So go all the way up to 6. And then let's just graph this 2 value as well. So 4 plus 4, that becomes 8. So that's up here. So our graph looks something like that. Again, sketch. So okay. Now let's graph our second equation. So we need to actually go down here in our graph because we have a negative y-intercept, and that'd be 0, comma, negative 1. So let's graph this. So we have a point right here. When x is 0, y is negative 1. And then let's draw the other point, which is plug in 1 here. 2 minus 1, which is 1. So it would be like that. So if you just connect the points like that, the graph would look like this. So this graph shows something different. The lines in the graph never touch. So this indicates that this has no solutions. So if you had tried solving for this, the x and y, no values would actually satisfy both equations. And for every time, an easy way just to identify a no solutions problem is just simply by looking at the slope and looking at the m value and looking at the b value. So the slopes are going to be the exact same if they have no solutions, but they're going to have different y-intercepts. And that makes sense. If you have the same slope you're rising and running the same constant. So that's not going to change, but the slope is going to be different, like the starting point, and that's going to affect like your overall graph. So yeah, that's a no solution one. And now let's go over a graph with let's go over our last example. So last example for graphs. So our third example will be y is equal to 2x plus 5 and y is equal to 2x plus 5. Okay, let's draw our graph. Again, make a prediction of what you guys think this is going to look like. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So we know the y-intercept is going to be 0, 5. So x is 0, then 1, 2, 3, 4, 5. And then we know that we're rising 2 and running 1. So rise 2, run 1. So we have a point right here. And let's just draw a graph there. Oh god. Again, sketch, so that's our first graph. And we notice that our second graph is the exact same. So usually what you guys want to do is just make your first graph a little bit darker, just to show that they're overlapping each other. So you just like trace over the line you already drew, and that would actually just be it. So based on this, these two equations have infinitely many solutions. No matter what value you choose for x or y, the equations are going to match. And the graph shows that too. So those are the 3 rules you guys have to know. You guys have to know there can be one solution that looks something like this. It has a point right here. There can be no solutions, and those are called parallel lines. They never touch or never intersect. And there can be infinitely many solutions where the graphs are just on top of each other. So yeah. So that's how you can solve the systems of equations graphically. Now let's go over how you can solve them algebraically. So when you're solving algebraically, there's actually 2 methods you can use. So the first, I'm going to call the substitution method. I'm just going to write sub for short. So this is the substitution method. So our equation is y is equal to 2x plus 1, and our other y value is other equation is 3x plus y is equal to 10. Okay. Well, we have 2 equations, and the first equation is telling us what y is equal to. So all we have to do is plug in this first equation into the second equation to solve for a value. So it says y is equal to 2x plus 1. So what the substitution method allows us to do is if wherever there's a y, we would plug in 2x plus 1. So this would just be 3x plus 2x plus 1. I'm just going to do that in parentheses because that's our new value, is equal to 10. All we did was we knew what y is equal to, so we just replaced that with 2x plus 1 for this y over here. That way we can just solve for x right now. So that would be 5x plus 1 is equal to 10, and then 5x is equal to 9. X is equal to 9 over 5. Okay, so we know what our x is. So all we gotta do now is plug in this x into our first equation to solve for y. We could plug it in into our second equation as well, but I think that's more complicated than it needs to be. So let's just, because right here we just already isolated the y term. So we know y is equal to 2 times 9 divided by 5 plus 1. So that means y is equal to 18 over 5 plus 5 over 5. And that means y is equal to 23 over 5. So the 2 values that like satisfy our 2 equations that we have right here would be when x is equal to 9 over 5, y would be equal to 23 over 5. So that's the substitution method. So sometimes this rule can be important for you guys, like if you just see like if you can isolate the variable and solve like that. But there's this other technique as well, and this one is called the elimination method. So the second one, I'm just gonna call ELI, elimination. So our equation for this one would be 2x plus 3y is equal to 12. And our second equation would be negative 2x plus y is equal to 4. Okay, what we have to do in the elimination method is basically create an addition system. Like, and probably when you're like, as we're like in a lower grade level, you guys probably learned like doing addition like this, like 4 plus 3, that's 7. You wrote it out like the 4 on the top, then 3 in the bottom, and then 7, and with the addition sign right here. You guys have to kind of use that same technique. So we're trying to add these values. So okay, let's see, the 2x and the minus x, those actually cancel out. So that's actually good for us. That's what we want to do. We want to eliminate one of the terms. So that would be nothing. And then we have 3y plus y. So that would be 4y. And that's equal to 12 plus 4, which is 16. And now we can just solve for y. So y is equal to 4. So now that we know our y term, we can actually just plug it into any of these equations to solve for our x. So let's just use the second equation. So negative 2x plus 4 is equal to 4. So what we would have is negative 2x is equal to 0 and x is equal to 0. So when x is equal to 0 and y is equal to 4, that would satisfy our system. And yeah, so that's the elimination method. Sometimes you guys have to like manipulate the equations to make sure it eliminates. Like, say if this was a positive 2, then we would have to multiply this whole equation by a negative in order just to like eliminate the x. Or say if this was a 4 instead of a 2, then we would have to multiply this equation, and this was negative 4. So then we have to multiply this whole equation by 2 in order to cancel out some of the values. So the elimination method, I think, is usually helpful when you don't have like it in like y equals mx plus b in slope intercept form, but it's another strategy to help you find what the x and y are equal to that satisfy both the system equation. Yeah, that's the end of the video. I'll have practice problems linked in the comments if you guys need it, and yeah, thank you for watching.